Let's practice some percent yield problems. I recommend pausing the video, working out the problems, and then coming back checking your work, because the best way to learn it is just to do it. So let's just jump straight into it and see what we can't figure out. So percent yield was the ratio between the actual yield and the theoretical yield. The actual yield was how much is literally produced in an experiment. The theoretical yield is how much you calculate through stoichiometry on paper. So our formula for percent yield is going to be percent yield is equal to the actual over theoretical times 100. So this is a very simplified problem. Let's pick out our information, plug it into our formula, and solve for the answer. So if you do an experiment where you expect to produce 45 grams, since we're expecting to produce it, that means it's theoretical. So the theoretical amount is going to be 45 grams. We only produce 32 grams. So this is our actual amount produced in the experiment in real life. So we only produced 32 grams. We expected to make 45 grams. What is the percent yield? So I'm looking for percent yield. So I take these values, plug it into my formula, do a little bit of algebra. So percent yield is equal to the actual, which is 32, over theoretical, which is 45. So I do a little bit of math there. 32 divided by 45, we get 0.71 continuous. I multiply that by 100, so my percent yield was 71.1%. And there's our answer. Pretty simple. Let's do another one. So if you react 5 moles of ammonia and only produce 85% of the expected ammonium, what's the actual yield? So this one's just a little bit different. Same formula though. Instead of looking for the percent yield, we're looking for the actual yield, how much we actually made in the reaction. So let's pick out our information. We react 5 moles of ammonia. NH3 is ammonia, so I got 5 moles. I only produced 85%. What is the actual yield? So the actual at 85% is what I'm looking at. So first we got to do a little bit of stoichiometry. Figure out our theoretical yield. It should be fairly simple since we're just doing a mole to mole conversion. So I got 5 moles of NH3. It's over 1. I need to change moles of NH3 to moles of NH4. So moles NH3 go on bottom. Moles NH4 go on top. Now fill in these two values with a balanced equation. There's 2 NH3s for every 2 NH4s. So 5 times 2 divided by 2 gives me 5. And that's going to be 5 moles of NH4 because NH3 cancels out. So this is our theoretical amount, how much we expect to make. But we only produced 85% of the expected amount. So what's the actual yield here? So percent yield equals the actual over theoretical times 100. So percent yield is 85%, but I gotta change that to a decimal. So 85% divided by 100 gives me 0.85. Set equal to the actual, which is x, over the theoretical, which is 5. Now to do this algebraically, I'm going to make this a proportion and cross multiply. 1 times x is 1x. 5 times 0.85 is 4.25. I divide by the value with x. 1's cancel out. X is 4.25 moles of ammonium. There is our answer. Let's do another one. This is the way you're typically going to see it. It'll be in a problem with generally more steps than just one conversion. So if we got 30 grams of ethane, so we pick out ethane, Ethane is C2H6, so I got 30 grams of this guy. And we produce 44 grams of carbon dioxide. So we're producing 44 grams of carbon dioxide. 30 grams of ethane produces 44 grams of carbon dioxide. What's our percent yield? So this 44 grams is our actual value. So we need to figure out what is our theoretical value. So we got to do some regular stoichiometry, do a mole conversion, mole ratio, and then convert back to grams or back to mass. So we got 30 grams of ethane. Put that over 1. I need to change grams to moles of ethane. So 1 mole of ethane is how many grams of ethane? So I'm going to be rounding my atomic mass on my periodic table. So carbon is 12, there's 2 of them, plus 1 gram of hydrogen, and there's 6 of them. So 12 plus 6. So it weighs 30 grams. So that's going to cancel out my grams of ethane. Once I got grams of ethane canceled and changes to moles, I need to change moles of ethane to moles of carbon dioxide. So moles of carbon dioxide from moles of ethane. So my ratio is 2 ethanes for every 4 carbon dioxide. So that cancels out moles of ethane, leaving me with moles of carbon dioxide. I would finally have to change moles of carbon dioxide to grams of carbon dioxide. So moles of carbon dioxide go on bottom, grams of carbon dioxide go on top. 1 mole of carbon dioxide is equal to 44 grams. Now we can cancel out moles of carbon dioxide and do a little math. So 30 times 1 divided by 30 times 4 divided by 2 times 44 divided by 1. So we should produce 88 grams of CO2. So this is my theoretical yield. But we only produced 44 grams. So what's my percent yield here? Well, percent yield is equal to the actual, which is 44, over the theoretical, which is 88. So that's going to be 1/2, which is 0.5, times 100. So I produced a 50% yield. And there is my answer. Let's do another one. So if 60 grams of iron 2,3 oxide produces 75% yield of iron, how many grams are actually produced? All right. So I got 60 grams of this guy. And we produce an actual at 75%. So first we need to figure out what's our theoretical. So then we can plug it into our formula with our percentage. So let's do our general stoichiometry to figure out our theoretical. So I got 60 grams over 1. I need to change that to moles. So 1 mole of Fe3O4 is equal to how many grams of Fe3O4? Let's see, iron weighs 56 grams, and there are 3 of them. Oxygen is 16, and there's 4 of them. So add all that together, and we get 232 grams. So that cancels out grams of Fe3O4. Once I got moles of it, I got to convert it to moles of iron. So moles of iron will be on top. Moles of Fe3O4 go on bottom. Now I need some values here. That's going to be our balanced equation. So there's 1 Fe3O4 for every 3 irons. That cancels out those moles. Then once I got moles of iron, I need to change it to grams of iron. So 1 mole of iron is equal to how many grams of iron? Well, iron once again weighs 56 grams. So that cancels out moles of iron. And now we can do our math. So 60 times 1 divided by 232 times 3 divided by 1 times 56 divided by 1. So theoretically, we should produce 43.45 grams of iron. But we only produce 75% of that. So what is our actual yield? So our percent yield is 75. So 75 changed to decimal is 0.75. The actual yield is what I'm looking for. Theoretical is 43.45. Stick that over 1. 1 times x is 1x. 43.45 times 0.75 gives me 32.59. Divide by the value with x. 1 cancels out. X is 32.59 grams. That's going to be iron. So there's our answer. Now let's do one more. We got 95 grams of chlorine gas. So 95 grams chlorine gas produces 40 grams of carbon tetrachloride. What's the percent yield? So our actual yield is 40. We got to figure out our theoretical so we can figure out the percent yield. Let's do a little bit of stoichiometry. So I got 95 grams chlorine gas. It's over 1. Well, 1 mole of chlorine gas is 70 grams. Cancels out my grams. Once I got moles of chlorine gas, I need to change it to moles of carbon tetrachloride. So moles Cl2 go on bottom. Moles of CCl4 go on top. I need some values. That's our balanced equation. Just a simple 1-to-1 ratio. Moles of chlorine gas cancel out. Once I got moles of carbon tetrachloride, I got to change that to grams. So 1 mole carbon tetrachloride is how many grams? Well, let's add that up real quick. Chlorine is 35. There's 4 of them. Plus 12 for carbon gives me 152 grams. Alright, let's do a little bit of math. 95 times 1 divided by 70 times 1 divided by 1 times 152 divided by 1. So theoretically, we should produce 206.3 grams carbon tetrachloride. But we only produced 40. So what's percent yield there? So percent yield is equal to the actual, which is 40, over 206.3. So 40 divided by 206.3 gives me 0.194 times 100 is 19.4%. And there is our answer. So if you got stoichiometry down pretty well, then percent yield is probably not going to be that difficult for you. It's just taking 2 values, plugging it into a formula, and solving for a third unknown variable. I hope this video helps, and as always, good luck on your tests.